Hello everyone, this is Manpreet Singh and I'm a member of AMCG Group BITS Pilani, and today I will be covering the hot topic computer vision. And as you know, computer vision is like among the hardest problem in robotics, and lots and lots of research and funding is going on this area. And you must have heard about augmented reality, and so augmented reality is just a composition of computer vision as well as computer graphics. So you must have seen the geeky games and all which use augmented reality. So I mean, it's a really hot topic. So let's just cover briefly about it. So first of all, what is computer vision? So by definition, computer vision means converting a still or a video data into some decision making or a referential form. So by decision making I mean, say you have an image of say a tumor, and you want to identify that the tumor is malignant or benign. So that is just like a decision making problem which computer vision can help. Or some referential data, I mean something like you are like deep blurring some video, or you're like stabilizing a video. So in that case you are not really making some decision, so you are just getting some pretty nice output. So that's what all computer vision is about. So as you know just at least the definition of computer vision, we'll quickly go to the applications, so that I mean to give you some little motivation about it. So the application, computer vision finds application in medical surgery, as you might have seen, and other than that, in traffic scenarios, like vehicle detection, speed detection, and other than that, computer vision is also used in like face gesture recognition. So I mean, if a patient is in pain, you want to tell if the patient is in pain or not. Or say you want to do some surveillance for some defense activities. So all these things you can do, and the most of the projects you might be doing in your cultural, in your technical festival, right? Okay, so I will be talking about all the tools which we use for computer vision. So you might have used MATLAB for it, or say you might have used OpenCV, you might have used ImageMagick, Magic++, anything you might have used for it. But from a personal experience, it's like OpenCV is the fastest tool if combined with like the Intel primitive library IPPU. So this OpenCV and IPP make the fastest combo possible till now. As you know, like it's the Intel's library, so they will provide for the hardware support for it with multi-threading and like parallel support as well. So OpenCV is really the best tool for computer vision till now at present, and it's open source as well, so you can tweak with the code. So I'll just like cover briefly exactly to show you what all exactly things you can do with OpenCV. So with OpenCV, like you can take a video input, you can like do some matrix manipulations, and you can like make GUIs which can be helpful, and so you can do some image enhancements as well. So something like your image has some lot of noise, so noise can be like salt, pepper noise, or any sort of noise, maybe due to your camera motion. So you can like remove the noise, and some other things might be like object detection. So OpenCV provides inbuilt support for like say face detection, person detection, and it also provides custom learning procedures for learning your own objects. Say you want to learn say a helmet, say for example, so you can just take a lot of images of helmets, and then just and then you can just use some pyramidal methods, and then you can learn these basically for recognizing objects. So like what I mean by pyramid is that say you have an image, So you have an image, and then you wanna just make a hierarchy over the image, and then learn the whole hierarchy. So this procedure, I mean, you can use for image detection, image recognition, and a lot of other purposes. Even for finding the flow of the pixel, the velocity of the pixels, anything like that. So and other than that, you can like use OpenCV for like making your own compression algorithms, right? You can like convert into a JPEG image by yourself by writing the whole algorithm yourself. And other than that, you can really work with contours. So contours are now something like, say you have an image and you have a lot of like floating island sort of things, and then you want to identify all these things, and you want to know the precise shape and everything about them. Say you have a human in your image and you want to know exactly how the boundary of a human looks like, and you may also like be interested in if the polygon approximation of it. So I mean, if the human looks like a polygon, how it might look like say a pentagon or something like that. So these have a lot of application. And other than that, you can use for inpainting purposes. So say your image, in your image, say this is the image of a hut, and then over it someone wrote something. Say I wrote AMCG. Now you want to remove this AMCG algorithmically. So there is an inpainting procedure as well. And other than that, you want to track things. So for a robotic application, you might want to track a ball, you might want to track a human. So all these things you can do. Other than that, you might want to know the velocity of the pixels. Say you want to know the velocity of a car, or you want to know the velocity of the camera itself moving, right? So you can do all these things. It's like known as optical flow for that sake. And other than that, we have like statistical models as well, like the Kalman filter and the condensation algorithms. These are like estimators. I mean, these are high terms. I mean, we'll be discussing about it, so don't worry really. And OpenCV supports machine learning algorithms as well. It supports decision tree, SVM, and clustering and everything like that, and ADA boosting and everything. And other than that, it also supports 3D. I mean, the high computation 3D, the so hot 3D in today's research. And yeah, so it performs like rectification, 3D reconstruction, projections, and like distortion calculation and calibration. Everything it performs. It has inbuilt support for that. So the main reason why OpenCV was made was that so it was made by Intel itself, and the person from Intel just saw in my MIT labs that the code the MIT people wrote, it was being used again and again by the ongoing students, and so finally it was like the origin of OpenCV. So it's this specific idea that you don't need to write the code from scratch. That's the origin of OpenCV, and we'll be discussing in-depth detail of these algorithms in next few lectures. And thank you for joining us. Thank you.